talk is going to be about preventive maintenance of small engines. If you own a home, most likely you own at least a lawnmower. You might have a power washer, a leaf blower, a weed whacker. And I'm going to be talking about all those kinds of engines today. Not so much larger engines, not too much two-cycle engines. If you have one of those pieces of equipment, most likely, and I almost guarantee, there's been some time you've gone out, tried to start one of those engines, they will not start, you pull till your arm's about ready to fall off, and you just have to give up. The purpose of today's talk is to limit how many times, or reduce how many times you have that problem by performing just routine preventive maintenance. I'm also going to get into some of the troubleshooting you can do when that does occur. And today's talk is basically I'm going to start with tools, go through some of the basic tools you'll need. I'm going to talk about how it is an engine works. I'm going to talk about how engines have evolved some over time, and different types, at least 3 different types of carburetors on engines, on these small engines. And if there's at any point in time that you have a question, just pipe in, let me know, and I'll answer those, and we can go off on it. And I'll open it up again for questions at the end. So first off, my cameraman is Cindy. Thank you very much. We're going to pan down to the tools that you'll need to use for this when you're servicing engines of this sort. So first off, basic screwdriver. I like these screwdrivers that have multiple tips. They have a common on one end and a Phillips on the other, or a cross point, more properly called. I take one of these everywhere I go to work on something. If somebody, I go to somebody's house to fix something, I bring one of these along because it basically has everything you need as far as a screwdriver is concerned for general use. Another tool you find these days is that most of the pieces of equipment that you'll be working on are not using standard Phillips screws. They almost use no common screws anymore. So most of them require Torx bits, or some of them require hex socket-headed screws that are called Allen. Some people call those Allen wrench types. So a tool like this has in it several different Torx type screws, bits, several different Phillips, and all of the socket-headed hex and square-headed hex, as well as a common straight screwdriver. Now this handle and all is kind of chintzy. I mean, I've used it for years. It does work. A little bit hard to use sometimes because the handle is fairly large and the tool is rather clunky. But the point is, these usually can have very good bits. And those bits have worked for me for years. So the thing is, as long as the bits are good, it's usually a workable tool. The next thing I wanted to talk about is just a general open-end box wrench combination. It's really good to have the set like this that varies in size. This happens to be a metric size from 8 millimeters up to 20 millimeters. Mostly you wouldn't really use anything above a 14 on a lawnmower engine or anything like that. Good to have. There are some locations that you would need a socket wrench. I'll get to those in a little. Well, okay, we'll stick with wrenches. So this is a small socket wrench set. This goes from about 4 millimeters up to 16 millimeters. The nice thing about this is that the low ones are quarter inch sockets that you can use with a hand driver. So that's good for taking some of the smaller ones out. Has a ratchet. The upper end on these has a regular ratchet handle. So you can do the larger things with this. You want to make sure that the set that you have has a spark plug socket. These have a rubber holder in there to hold a spark plug and help you not damage the tip of the spark plug, keep the wrench in alignment a little bit. And one thing about spark plug wrenches is there are several sizes of spark plugs, so you need to make sure that you have a spark plug wrench that's going to match. This set back here is far more complete than you would really typically need for lawnmowers. I like this set because even up to the larger size on these deep sockets has hexagonal instead of a 12 point, whereas this one's a 12 point. So see if I can get those aligned. This one's a 12 point. This is a 6-sided socket. So these are really good for not stripping out a bolt. They will actually put more torque on the bolt, enough to break a bolt versus stripping the head of the bolt. So, it's good to have that. It's good to have the deep socket set. This is an English set, but I still use it on many metric cars. You can kind of use them interchangeably. There's only a few sizes that don't work out too well that way. Continuing on with small tools, toothbrush. Just keep an old toothbrush around. It's good. I'll show you what I'm going to use that for a little later on. These are called Kelly clamps medically, or hemostats. These never were made for hospital purposes or medical purposes. These are really mechanic set. The nice thing about that is they'll clamp and hold, and you can take your hands off. I'm going to show you what to use that for a little later on. I'll call these mechanics tweezers. You can get these just about anywhere in an auto parts store or whatever. They're really helpful for pulling a screw out, for starting a screw. Especially as you get older, your fingers don't work as well to hold on to these small things. So I find those quite useful and use them a lot. I have at least 3 pairs of these in each place that I'm working, each shop. As far as wrenches not to have, this is an open-end adjustable wrench. I have these. I take them when I go on a job or go out to try to work on something. I'll take one along. This is a tool of last resort. You really, if you can get away from using it, do. If it's the only kind of wrench you've ever had and you felt like a klutz, that's the reason. Don't use this. Get a better set of wrenches, because these are very frustrating to use. Another tool not to use, but yet I use it, is this. I'm gonna get further away for it all. This is a fuel transfer pump, or a transfer pump. Now I don't believe they were originally marketed as a fuel transfer pump, but I think the regulations have been laxed enough that now they're actually selling them for transfer of fuel, which they always used to be. This thing leaks gasoline like a sieve from this point down. And in fact, if you read it, it tells you that the discharge, it actually is intended to discharge gasoline down this pipe the whole time that you're running it. And it does. So unless you have, and they tell you you're supposed to immerse it into the gas tank this deep. Well, where are you going to find a gas tank that deep to stick this thing in? I do use this to transfer fuel from a 5-gallon can I had into other gas cans, but that's the only thing I'd ever use it for. Another example of how wonderful it is. You can see it does not sound like a quality product. So actually, I forgot to do my public service announcement, and I'll do it sitting down here instead of standing up. During the process of doing this work, you're going to be having to transfer gasoline at one point or another in time. Sometimes that transfer is going to be usually it's into the tank to fuel it, which isn't a problem. you're used to doing that. But don't do any fuel transfer in an enclosed garage, in your shed, on your deck, or any attached part of the house. Gasoline is highly flammable, highly volatile, and dangerous to be working with. So anytime I'm doing a fuel transfer, I do it out in my garage, or out of my garage, out in the driveway, in the open air. I have a fire extinguisher handy. So keep all those things in mind and be safe. The other thing is gasoline is highly toxic and poisonous. Don't discard it in the grass or anything like that. If you live here in Calvert County, they have an annual toxic materials disposal that you can go for free, and they will take them and get rid of your bad gas. Yeah, that's about it on that topic. So the other tool, now this is not one that you can buy. So then you get to the point, as I said, you're going to get to the point where you need to transfer fuel out of a lawnmower or an engine, and there really isn't any good tool I've found that anyone markets to use or to do that purpose. You can try a siphon bulb. They do have those. Definitely don't try to use this. What I have devised is, this is a vacuum pump. They're available at most auto parts stores. They run about $25 to $35. And I fabricated from a quart ball jar, I fabricated this that has two hose attachments on the top. And what I do is I put the vacuum tube on the top of this, and I run another line over here and put it in the engine and suction here, and the fuel that I want to get out comes into the jar. Now, OSHA would never have you put fuel or store fuel in a jar, but the big advantage of this is once you've got it in here, you can look to see if the gasoline is contaminated. And frequently, if I'm working on an engine that's had problems with bad gas, you'll see in the bottom, you'll see the contamination in the gas, debris, water, whatever, and this jar will allow me to verify, see if that's there or not, and then I pour it off into a can via a funnel, and then that's it. At least that way, I've used that to verify that the gas is good or not. Now, you'd have to come up with your own approach for this. Sorry about that, but no one makes a tool, I think, to do this. Now, the other thing is, anytime you're working on these machines, you're going to get your hands dirty. So lately, they've had mechanics gloves available. They are available in very thin, like 3 mil. What you'll find, and what I've found, is a lot of times when I'm working with these, they will shred in about 30 seconds after you start using them. So you want to buy a thicker one if you can. But you can try you'll get less feel the thicker they are. This size here, this is one I picked up at AutoZone. It's called Fixtures, and these are 14 mils thick. They're really quite thick and quite durable. You can cut them, but you can actually work on an engine several times with these on and not actually shred them. Another thing that you'll find in the auto parts stores are mechanics gloves, and I really was surprised. I think I got these for Christmas. I didn't think I'd use them, and I use them a lot of the time, especially when I'm working on the car. It's more important there, but you'll find that you'll get nicks and cuts on your hands if you don't, and if you can use these for doing a lot of the work on, say, a car or a lawnmower, and when you need detail work, you'll have to take off the gloves and use your hands. So then that gets to the point where you are going to get your hands dirty. So the auto parts stores sell several different options on hand cleaners. They all work really well. Some of them are lanolin based. But actually something that I've used now at home, Dove soap. I mean, if you just take Dove soap and rub it on your hands really well. It's gentle on your hands, and it does a good job of taking oil-based contaminants off your hands. So any questions about tools? Okay, so moving on to my first guest.
Everybody's
Well, they can unmute if they want.
okay.
Yeah, John.
Yes.
Why don't you patent your little pump there with the ball jar?
Well, I think for the same reason that no one manufactures it is that the liability issues for selling such a thing in the open market would be a little bit onerous. And I know that you cannot store gas legally in most states. You can't store gasoline in a glass bottle, you know. So, but it's the best thing. You can't put polystyrene, which is a clear plastic, fairly clear plastic, can't stand gasoline one bit. So, I mean, it really tears it down pretty quickly. So, glass is really the best thing for my purposes. So that's what I do. Any other questions? Could you swing the screen down a little bit? It looks pretty dark for me. Yeah, that is a good point.
John Overstrom.
Okay. So my first guest appearance here is this over 70-year-old Briggs & Stratton lawnmower engine. This engine and I go back a long ways. It's the first engine I ever started as a kid, and I have mowed a lot of lawns with this. So we've been together quite a while. The main reason I selected is it's a horizontal shaft engine, which allows me to show you some of the inner workings a little better for the camera. So this is the head up here. I'm going to take the head off, which would normally be tightly bolted down. And now we can see the innards of the engine. This is the piston here. This is the intake valve. And this is the exhaust valve. So here is the carburetor where air comes in here. It's mixed with the gasoline and comes in through the intake valve and into the cylinder. And here's the exhaust valve, and see that's aligned right with the exhaust valve. So I'm going to show you how the cycle of the engine works. So all internal combustion engines work on the same 4 cycles. There's intake, compression, power, and exhaust. That's true for an engine of this class. It's true for your car. It's true for a diesel. It's even true for a jet engine. They all use the same 4 cycles. The only difference on those engines is how the fuel gets mixed with, how and when the fuel gets mixed with the air, and how it's ignited. And other than that, they really are the same 4 processes. A 2-cycle engine does the same thing, except it kind of short changes that process. I'm not going to talk about how the 2-cycle works unless someone wants it at the end. We'll see how we go for time and if everyone's heard enough or not when we get to the end. So here's how a 4-stroke engine works. So you see the piston goes up and down in the cylinder. This is the piston. This is the cylinder, and are rings on the top of this piston that seal it very well to that cylinder. I'll show you how well it does. So if you,
Oh yeah,
you can hear, hopefully you're hearing that sound sucking my hand down. Can't get my hand aligned right. So there's a lot of suction in there. It's sealed very well. So now let's get the engine in the right orientation. So this is called top dead center on the piston. There's a crank in here attached to the crankshaft, which is now at its highest position. And as I rotate the engine, it's going to go swing downward and pull the piston down. So the piston is just starting to go down, and you can see, hopefully in the light of it, you can see that this valve is rising a little bit. So that's allowing the air from the carburetor to come through and go into this cylinder. As the piston gets all the way down to the bottom, this valve just closed. So that valve, now the piston's all the way at the bottom, the cylinders that has drawn in the fuel air mixture, And now the piston's coming back up on the other half of that stroke. And the air, the mixture can't go anywhere because it's confined in this small space in the head. It gets up to this point right there, and the spark plug fires to light the gases that have been confined in this small area, and they burn very rapidly. At that point, the engine continues on its motion, and then it pushes it down, just like I'm doing with my finger there, pushes it down to the bottom of the stroke. And now that charge of fuel has been expended, and the engine's momentum is going to carry it on through. The piston's coming back up. And now you see that the exhaust valve, just as it got to the bottom, the exhaust valve is opening. So now that exhaust valve is fully open, and the piston is coming up, driving those expended hot gases out through the valve and out through the muffler. And now we get to the top, and we're done. It's all over. We're through the 4 cycles. So that's the 4 cycles. There's intake, compression, the power stroke when the engine's actually getting power out of the fuel and air mixture, and then the exhaust stroke. So that's why it's called a 4-stroke engine. It's actually accomplished in 2 rotations. So the mechanisms that are in the engine, the mechanical parts that make that all happen are the crankshaft that's attached. This is the crankshaft here, right in there. There's another gear that's on the crankshaft that drives a camshaft, and that rotates at half the speed, and that's what makes the valves open and close. The camshaft is right down in here below where those valves are. And that's really all the mechanisms that are inside this engine. I mean, that's it. They're very simple, not that much. All of these engines are very simple. They're made as simply as possible, which makes it easy to take care of them, to tell you the truth. None of the bells and whistles that you have on an automobile are present on these engines. The computer control, electrical systems, any of the emissions controls, none of that's present here. So as far as what's going on down inside that engine, here is a kind of a cutaway. This is an engine that's off of a backpack leaf blower, and you can see the crank. There's the crank going around on the crankshaft, and you can see the connecting rod there that's going up to where the piston is. And the piston's going up and down in the cylinder here. Now, the reason I'm showing you this engine is that the only reason I have this engine is it died because it had inadequate oil in it. So I want to point out just how there's the first preventive maintenance item that I'm going to discuss. Look at this. As I said, these don't have any fancy things going on. There's no oil pump. There is no oil filter. The only thing this engine has to lubricate itself is the bath of oil that would normally be sitting in the bottom of the crankcase here. Now look at the oiling distribution to the engine is accomplished by this little finger sticking down here, which is an oil slinger. So you can see the spacing here. There is a half of an inch at the bottom of this crankcase, and until you have a half of an inch of oil in there, nothing's getting lubricated. Now, if you get up to this part where that oil flinger is, and then you're starting to be throwing oil around inside here, and it's just kind of randomly being thrown around inside the crankcase, and hopefully enough, I mean, by design, eventually some of it flies up into the cylinder and lubricates those parts, and it's lubricating these parts down here. So it's kind of a random act almost, and yet, I mean, it works. But the point is, you really need to have the right amount of oil in here, because if you only have a half an inch, you're not going to get any. If you have an inch, you're getting the right amount. You don't want to get enough oil up so that it's hitting these parts because then you're kind of working the oil into a froth and foam, almost making whipped cream out of it. You know, so they'll always tell you, do not, you know, overfill it. But then again, it's obviously critical that you don't underfill it either. These small engines usually ship with only about a small bottle of oil, like 4 ounces. So on these small engines especially, be sure that you get enough oil. It's also true for the bigger engines. But so number one, first, preventive maintenance, make sure you've got the right oil. Check your oil frequently. Especially if it's an older engine that's starting to burn oil, it's easy for it to be consumed. This engine, while I've got it here, this is an overhead valve engine. They're a little bit more advanced than an older engine like this. All automobiles have overhead valves, and in this case, so they have rocker arms in the top that drive the, so there's a push rod that comes up from down inside the engine. They come up through these tubes, those tubes you see there, and the push rods push on the valve, on these rocker arms, and then that depresses the valves over here. So it's a little more advanced because the airflow is a little bit improved from this flathead engine that the other Briggs and Stratton is. So any questions about that part of the presentation? So moving on, so that's all I'm really going to talk about, the mechanical parts of the engine. To tell you the truth, they're quite reliable. And as long as you keep enough oil in there, you're going to be in pretty good shape. And there's almost nothing you'd ever want to do in here. If you get to the point where this part of the engine is wearing out, you know, it's time to retire it. You know, there really isn't, I mean, I do it for a hobby purpose, but mostly I would not recommend worrying about doing that. You just keep the oil in there. You can change the oil maybe once. I only do it about once every 4 years. Other than that, the mechanical parts of the engine will outlast the housing on your lawnmower typically. And that's the last 2 lawnmowers I threw out. I threw out because the housings were falling apart, not because the engines were bad. Okay, moving on to the next mechanical part here is the flywheel. The flywheel on any engine is there in order to store the momentum that you get from the power stroke and then drive the engine and carry it through the rest of the cycles where there's no power coming in, and also kind of smooths out the torque. So that's the primary purpose of a flywheel, but you can see this one actually ends up serving 3 purposes. It also has the cooling fans, and all the engines I'm talking about are going to have cooling fans on their flywheels, except for leaf blowers. Will typically take some of the air from the leaf blower and use that. So the air comes into the center here, goes out into the housing that I've removed, and then goes back in here where it's directed across the fins on the cylinder. The other thing the flywheel does is it has 2 magnets on it. Those are magnets. Those magnets make a magneto, which is another way of, it's basically a very high voltage generator. And those 2 magnets are aligned so that when the piston comes up to the top, they're in alignment with the coil, with the metal part of this coil. So this is an electric coil, and this old engine actually has points and condenser that are underneath here. No modern engine has points and condenser. They have on this one here, modern design, there's no points and condenser. The only electrical connection they have is this. This is to stop the engine. Other than that, this is all solid state. They put some solid state electronics in there. And so you don't ever have to worry about points and ignition on points and condensers on these engines. So again, now another along the lines of things that can go wrong. This solid state, you know, magnets don't fail. electricity doesn't really fail. Basically, I've never seen a failure of a magneto on most of these engines. I guess I have on an outboard, which was exposed to really bad environment. I have, but mostly I've never seen a failure on a magneto. So very low probability of failure. Oh, and now I'm going to regress back to where I was talking about the engine. Sorry, I skipped a part. The one thing I wanted to point out while I was talking about the engine is that there's only 3 elements you need for an engine to work, for it to run properly. You have to have a good oil or a gas air mixture. You have to have good compression, and you have to have a spark. If you have those 3 things, the physics are that the engine will run. I mean, the engine will run if those 3 things. Of those 3 things, the compression is pretty much assured by the mechanics of the engine. The spark is pretty much assured by just the simple physics of the governor, or of the magneto. And so that leaves the #1 cause of failure of any of these engines is always going to be fuel air mixture. And whether or not you have good gas, whether or not you're getting the right mixture into the engine. So we'll move on to the carburetor. So this is the carburetor on this engine. And I'm always amazed at this design. It's really I very much love this design. It's simple, it's very effective. So the gas tank is here, the carburetor is here. By mounting the gas tank directly underneath the carburetor, it eliminates having to have a carburetor float. The gasoline tank acts as the carburetor float. It acts as the sediment bed. If you open the lid, and down in here, they'll have a depression directly below where the fill is, so that you can look down in and see if there's any debris accumulating in the bottom of the tank. The carburetor does not draw fuel directly from the bottom. It's a little bit up, so if there's debris in the bottom of the tank, it doesn't suction it up mostly. So it's really was a very far-thinking design, and it's very much in use still today. The same layout. So how does the carburetor work? The air is drawn in here. There's a small tube in there that goes down into the gas. It's got a screen on the bottom to suction up the gas. And as the gasoline is drawn through here, that's spraying a mist into the carburetor. And so this mist and air combination is coming into the engine. This is the throttle here. And the other thing here is the choke. So you can see that this has a manual choke. So when I used to start this engine, you push the choke all the way closed, give it 1 pull, that would draw the gasoline up into the carburetor and into the engine and basically give it a prime. Then I would open this part way, give it another pull, and it would start. You wait till the engine warms up a little bit, and then you open the choke all the way and you adjust the throttle. And that simple process, I mean, this thing always started, to tell you the truth. I mean, I never actually had to take this engine apart ever because it always worked. Most of these engines, especially lawnmowers, are going to have a governor. So this mechanism here, you see a spring attached to this throttle arm. There, you can see the spring better that way. So there's a spring, and what's going on here is I'm increasing or decreasing the tension on this spring. That's right now trying to hold the throttle full open. And you see this plate here, the air pressure that's caused by this fan blowing up and trying to go out through here pushes against this vane on the engine, and that sets the speed that the engine's going to run at. So that's a governor. Mostly you won't see governors on any engine that you're manually controlling all of the time. Like if you're controlling the speed, you won't have a governor. So I'm going to move on to the next engine. So if you can swing the camera. Keep going. Okay, so this engine, instead of being a horizontal shaft like this, is a vertical shaft. All your modern lawnmower engines are going to be a vertical shaft engine. But this is really the great grandchild of this other engine. So the only thing they've done is, well, actually, I'll show you. So here is the, here's the air cleaner, and underneath here is the carburetor. The tank is still on the bottom. They still have the little dimple down here in the bottom so that you can see where if there's any debris. They have replaced the choke. On modern engines, they'll have a bulb here, and that will put that first raw shot of gasoline into your engine. Now, word of caution on these, they say 3 times, push this bulb 3 times. I would never push it 3 times. If you push it 3 times, you could more than likely flood the engine. So what happens, this is basically a squirt gun. It actually squirts gas straight into the engine. On the first push, you're just priming this pump. It's not actually doing anything to push any gas. The second one, I can feel the resistance in that. I know that I've pushed fuel and squirted fuel into the cylinder. Don't do the third unless your engine won't start. I mean, because you're going to flood the engine. So I always be cautious about how many times you pull it. 5 is not good, so don't push it too many times. So another routine maintenance on these engines is to keep the air filter clean. I had run this engine without cleaning the air filter off so that I could show you guys what was on here. And unfortunately, before, I had pollen stuck all over this air cleaner. But now you can see a lot of it fell off the last time I ran the engine. But so at any rate, I'm just going to take and scrape off this excess pollen that's on the intake. And this is just a piece of foam rubber. So that pretty much has it clean. I might do a little bit more if I wasn't on camera, but basically I'm trying to get that. This had built up to have a layer of pollen. So what happens if you start getting too much blockage on these filters, it's as though that choke was closed, and then the engine starts running too rich. It starts running too rich, the spark plug's going to foul with carbon, and it's going to eventually stop running on you. So make sure you check this, especially in the spring when you have a lot of pollen, or in the fall when you might have a lot of dust that your engine's sucking up. It's right down here where all sorts of debris is flying around in the air. So make sure you check this every now and then. Check your oil every other time you run your lawnmower. Those are pretty much the preventive maintenance things on these engines, on this particular class of engine. This has the governors. Everything's basically still the same on this 40-year younger lawnmower engine than this one, or 70-year younger. Okay, so any questions on that part? Maybe you can swing the camera up. Okay. So the next thing I'm going to talk about is fuel and gasoline with alcohol in it. All of the gas that's available to us these days includes ethanol. It didn't used to be the case, but somewhere in the 70s to 80s time frame, it got to the point where they were putting more and more ethanol in, and it was very common. And now there is no place in Calvert County that you can go that does not have ethanol in the gasoline. That's good and it's bad. The reason it's good is back in the day, so water does not mix with gasoline. Back in the day, before this, if condensation formed in your tank, it would settle to the bottom, the gas wouldn't mix with it, it would start to rust the bottom of your tank out, and if that water accumulation got to the point where intake of your fuel pump is drawing that in, it'd get into your fueling system and you wouldn't be able to, it'd stop your car from running. Back then we had what was called dry gas. You put this dry gas in, or gas line antifreeze, you put that in, that would find its alcohol. If you put that in, it would find that water, mix with it, and then it would go up into the gas and be not be insoluble in the gas, and then you could burn, the alcohol will burn. So the bad side is that the alcohol is hygroscopic, so it absorbs moisture out of the air. It's good to absorb a little moisture from your tank, but it's really aggressive at finding moisture in the air that wouldn't have been a problem in the first place. And it does that very well. And eventually, if you have an engine that's sitting for a while and out in a moist environment, it will keep accumulating more and more water in the gas until it gets to the point where it does separate. And my experience has been that the alcohol that's in the bottom of a tank or in the bottom of an engine is more corrosive than just plain the water would have been. So it gets to be a real problem, especially on engines that are used infrequently or used in a moist environment or exposed to a moist environment. And that gets me also back to another thing on preventive maintenance. Storage of how you store your equipment is very important. We happen to have a garage or a shed that I keep all these machines in. It's very dry. It's off the ground. It's got it's got a floor that's elevated above the ground. We get good circulation around it, and so that shed really is a good dry place to keep these engines. I've never had any problem with moisture in there. But if you're running a marine engine, or if you're running an engine in a power washer, or you're running an engine that you very frequently use, a snow blower or a log splitter, you don't really want to keep the gas in those engines because it will keep accumulating and you're not using them often enough. It's not a problem for cars because you're running them fairly frequently. It's not a problem for lawnmowers too much because you're running them often enough to cycle through that bad gas. But if you're trying to store gas in a gas can, a container, make sure it's not vented, don't keep it there too long, basically. And to that end, I'm going to show you the next engine. Let's see, get that down here.
Could have let me do it.
Yeah, I could have. Okay, so this is a power washer, and this engine configuration is significantly different than the other. You see, this one has a gas tank that is above the carburetor, and this is fed via gravity out of the bottom of the tank and down into the carburetor, and the gasoline sits in this bowl. So what happens is if you have that water separation, or you start getting any of that all will go into the bottom of this tank and then work its way down the gas line and into the bottom of this carburetor bowl, and it'll sit there and accumulate. And what's even worse is, see, there's no shut-off valve between here and here. So if you keep gas in here, there's a constant supply of fuel that as the gasoline evaporates out of this carburetor, some more just keeps flowing in. It just keeps flowing in. So if you leave this engine sitting with gasoline in here, it will keep refreshing this gas, and with the worst version of the gas it has, because it's the sludge from the bottom of the tank coming down here. So I always run this engine dry. I never store it with gasoline in it. So suppose, now the last time I ran this engine, I actually accidentally hit it with a wand a few times, and it stopped on me because it sucked the moisture in. And then it stopped, it came down here into the bottom of the bowl. So I'm going to show you what to do if that happens, and maybe it's not really a bad thing to do as a routine affair. So since I don't have any way to shut off the fuel flow, I use these clamps to go onto the fuel line and squeeze it shut. Now it looks like it's so stiff now I can't do it anymore. So that's not a good show and tell, but
Wow.
yeah, that's stiffened up a lot. So at any rate, I would usually do that. I'm going to have to replace this line because it's so solid I can't even crush
Squeeze
it
it.
slightly with that. So then after you've got that done, then you would take a wrench, and there is a nut in the bottom of the bowl. Unfortunately, there's no way to stop the gasoline from coming out. As soon as you start turning this nut, gasoline is going to be flowing out of here. I'd like to capture it, but I've never found a container that is really the right size to get under there that I can also get my fingers under there to access. So you take this off, and you'll find a lot of times that this will have, I've found up to 1/2 of an inch of rusted, corroded junk in here. I mean, it can really get pretty bad if you keep it for a few years. So so that's the #1 place to clean. If you get this apart, this in here is the jet that controls how the fuel flow into the carburetor. And if you find a bunch of accumulated junk in here, you need to clean out all of those little holes and make sure the gasoline can flow properly. If you clean out this bowl and put it back together, 90% of the time you will get this engine running again. This is the float here, and just like the float on a toilet, it is when it's down like this, the fuel can flow freely. As it gets enough fuel in the bowl, it gets to that point, and it runs there's a needle valve in a seat, and it runs that needle up against the seat, and the fuel stops flowing in. When you're putting these back on, by the way, you see there's a low spot and a high spot. These, on some engines, it's critical that you put them back together correctly, because if you don't do it right, it's not aligned. Well, basically, you have to align it with the hinge. So this is an operation you would always want to do out in your driveway. What I would have to do on this engine is, the nice thing on this one is I can take this gas tank right off and tip it down, and I'll have to do that if I want to replace this line again. Okay, what else was I going to do on this engine? What time we have? We're running low on time too. Okay, I'll move on to, can you move the camera now? To over here. So the last carburetor I showed you, different than the Briggs & Stratton lawnmower engine, that was a gravity-fed carburetor. Now this is the kind of setup you see on most of the more modern portable engines. These carburetors are basically an entire fueling system. Fancier than those other two, have a lot more features than the other two. This bulb is a primer bulb to prime, usually the instructions on these will tell you push them 10 times. In that case, when they tell you to push it 10 times, you can push it 20 times if you want. There's not really an issue. You're not worried about flooding the engine, because what you're actually doing is you push this bulb, is you're drawing fuel up from the tank into this, and you're priming a fuel pump that lives right inside of there. And you're priming that fuel pump, and the more you push it, what you're actually doing is the overflow is going back down and it's just squirting back down this clear tube, and it's squirting back into the tank. So, oh, Cindy's got a question.
So what is that from? What kind of machine?
This is from a backpack, the same, I think the same backpack leaf blower as the other,
Okay.
that engine I showed you.
That little engine.
Right. So the, yeah, so now I'm going to remember, where was I? So yeah, basically you're priming the pump in here. What you want to look for is to see that you don't have a lot of air bubbles in this visible line. If you can see, you can also look at the top of the bulb and see if you've got good gasoline flowing in there. You don't necessarily have to have all of the bubbles out of the primer bulb. If it's rotated this way, it's usually easier, but a lot of the machines have it this way, and you're always going to keep a little bit of a bubble in there. So the things that happen on these engines that make them fail is these primer bulbs get brittle. And so you're pushing on these and they'll get a little crack. And once that crack occurs, you can't prime them properly, and the fuel pump won't work properly. These are readily available at the hardware store. Here's, I don't know if I can see them, or if you can see them, it looks flared out from here, but they're readily available at the hardware store. Can you see it?
No, hold one in your
Yeah, I
hands.
guess it just looks flared out to me.
Hold it against your shirt.
Yeah. Boy, I'm just too bright here.
Mm-hmm.
So at any rate, you can buy those bulbs as a replacement kit at hardware stores. There's only 4 screws you have to remove in order to take those off. The other thing that happens is these lines get brittle. And so the intake line will get a crack in it, and you can't draw fuel up from this thing. And so the other thing is, you can hear that, but there is a ceramic weighted take-up in the bottom that sucks up. The ceramic is a filter, the pre-filter for the carburetor, and that moves around. The weight causes it to move around with gravity as you move the piece of equipment, so it's always staying in the bottom. That means it's also flopping around in there. So once these tubes start to get brittle, I've seen them break off inside and leave that thing rattling around in the bottom, and you're trying to draw fuel from maybe this high in the tank, and it doesn't work. So this carburetor has a fuel pump in it, it has that primer system, and it has the carburetor bowl function in it because it's got a little fuel pressure regulator. So it's much more sophisticated than those other 2 carburetors. But nonetheless, they really aren't that hard to repair. You can buy a kit that includes the little gaskets. It is a little bit more like working on a watch than working on an engine, but you know, it's really not that hard to, if you can get at it. The problem is a lot of these machines have so many pieces of plastic on the outside, makes it hard to maintain or to get at the problem sometimes. But once you get at the problem, usually it's not that hard. Okay, so now I don't remember where I was going to go next. We run to the end. So next thing I was going to do is engine won't start problems. So let's move the camera back on again. I'm sorry.
Okay.
Where are we?
Just tell me what you want.
Yeah. Okay, so suppose I'm trying to start this engine and I'm here pulling endlessly on it and it won't start. The first thing you do is when you're, I guess if you raise it up, you can see it.
Raise it up.
Yeah, so the first thing you do is as you're pulling the engine, feel if it feels right. Feel if you have that compression, because remember what we're trying to do is verify the three things. We're trying to verify compression, spark, and gasoline presence. So you're pull this engine. If you feel that resistance, then you know that there is enough compression. The next step, and like I say, these are the least probable problems, but they're the easiest to check for. So it's best to just go with the easy first. So I'm going to take the spark plug off of the engine, or out of the engine. And the first thing I'm going to do is I'm going to look at the condition of the spark plug. Now you can see on this spark plug, you can see the insulator is nice and clean, nice and white and clean. There's no real issue with it. There's no buildup of carbon, no buildup of oil, no deposits. There's just a small amount of carbon over here on the edge, and that's not a problem at all. So this, the other thing you should be looking for is oil accumulation would indicate that your engine is getting old and maybe burning oil. You need to be monitoring that. A lot of carbon buildup would be because the engine's running too rich. And in combination with oil and carbon, or oil and say fuel, it will kind of short out the spark plug and it'll stop sparking. So it's best to have, say, a backup spark plug you can use to put in there. They're cheap, so it's really not a problem to have a second one. Personally, I don't actually do that. I usually just keep using the same one. I hit it with a torch to burn off debris if it builds up, and I wire brush them off. So the next step is to take that spark plug, put the coil wire back on, and put it on a part of the engine that's grounded, and then pull. And as I pull now, I can see that spark. I know you can't. You're not going to be able to see. Okay, here it is. You're not going to be able to see that spark on camera, and you're not going to be able to see that spark out in broad daylight. But so now that I know there's a spark, I know that I've got compression. The only thing left is the carburation, the fuel, and I would do what I already showed you. That would be to remove the bowl and provide this engine with the cleaner gas. So let's see, other things, other notes. So we are running out of time, so I'll wrap this up. So the key takeaways for maintenance and preventive maintenance of your engines: check your oil level, every now and then. If it's a brand new engine and doesn't use oil, then you really don't have to worry so much. But as an engine ages, I had one that I was adding oil every time I ran the engine because it was really burning it, and so if I had not checked it, then I would have ruined the engine. Clean your air filter. I've showed you how to do that. It's paper. Some engines have paper paper elements instead of that foam element. Let's see, here it is. So this is a paper element filter. You can replace these. A lot of times, all I do is rotate it around, or I whack it on a surface to knock the dirt out of there. So that's the other type of air filter you're liable to see here. Engine storage is really important. Try to keep your engine in as dry and sheltered a place as possible. Underneath your deck with a tarp over it, that's not so good. I mean, it will rust the engine out. It'll get moisture in your gas. Something you'll be fighting that all the time, and don't be surprised if an engine doesn't work right for you if that happens. If you've got an infrequently used engine, like a power washer, a log splitter, anything that you very rarely actually use, or snowblower, take the gasoline out of that at the end of the season. And don't keep your gas too long. So that's about all I've got time for. So, okay, does anyone have any questions now?
Well, I just have one. Does that Briggs & Stratton engine still work?
Not without the head on it, but if I
Well,
put the head back on it, it would.
I mean, if it's together.
Yes. Yeah, the last time I tried to run it, it ran just fine.
That's pretty cool.
It got retired from lawnmower service long before lawn mowing duty long before I did.
So
On the subject, John, on the subject of your cleverly executed device that pumps the gasoline out of a tank, a small tank,
Oh, that.
if you just don't call that a storage vessel, but an inspection vessel, you're not storing gasoline. You're putting gasoline in there just long enough to see if there's debris or water or something like that,
That's true.
Yeah.
and to get it
That's
out.
true.
So
I
careful what
use
you
that
call
to
it.
suction out around the bottom of a tank. And I take it down to the boat once a year and I suction the main tank that we use, and I suction all around the bottom of that tank, trying to see if there's any moisture or
Sure.
debris that's accumulated.
Right.
And anything I find, I pour off and separate it out, put the other gas back right back in. But that little residual, you've got to discard.
yeah.
John, if you have debris in gasoline, is it possible to filter it, like use a paint filter or something to run the gas through so that it takes the debris out, or is it already fouled?
It really settles mostly. I mean, you don't really have to work that hard at separating it out. I mean, it does settle. The gasoline is so light and the debris is so dense, it settles to the bottom almost always. And if there's water in there, it's always in suspension in the water, but I've never really seen it in suspension in the gasoline.
John, would you
All these engines have strainers on their intake too. Actually, so you know what that brings to mind? I was going to talk about on the Briggs engines, they do have a problem where if you get a leaf or a lawn, let's say lawn clippings, occasionally get in there. And I have had the situation where they will float around in the gasoline, and you're running your engine, and eventually a blade of grass gets sucked up to the screen on the carburetor, and another one gets sucked up, and another one gets sucked up, and all of a sudden your engine's performance is not performing right, and it'll even stall out. But then there's 5 minutes later that stuff all falls off of there and works again. So I use these to go into that carburetor, into the gas tank, and pluck that various debris that's large enough for me to pluck off of the bottom of the gas tank.
Or the top.
John, would you talk about gapping spark plugs, whether that's any longer necessary?
I don't do it anymore at all. These engines, especially automobiles, used to. You're running those engines for hours and hours, and you would end up with the spark gap at the end of the spark plug. You're trying to let's see, where am I here? You're basically gapping would be adjusting the outer electrode on the spark plug to the right angle. Spark plugs these days, they cost $350. So it's really not worth gapping. And these engines almost never burn out a spark plug or wear them out. You don't see any wear at all. The magnetos don't have nearly as much energy as, say, an ignition coil system or a modern electronic ignition system. So there's not that much energy going there to burn the elements or the electrodes on the spark plug either.
Hey, John, this is Cheryl. On the throttle, when you open and close the throttle, is it increasing both the gas, or if you're opening it, is it increasing both the gas flow and the air flow, or just one or the other?
It's the overall flow into the engine. The throttle is the last step. So yeah, you're really controlling flow into the engine, and it's really mixed right before the throttle plate.
Okay.
Was there another question?
John, Steve here. In your talk about ethanol in the gas, and trying to research on some of my problems, there's a lot of people on the internet that bemoan the fact that there's ethanol in the gas these days, and should try to get something without it. But I missed your point that you were bringing up about that. I mean, that I can't buy it without it. So how does that impact the performance?
Well, you mean as far as how well the performance of the gasoline or
just the overall lifespan of an engine?
well, you know, it really works fine in your car because you're running plenty of gasoline through. There are materials in some of these engines that don't like the ethanol. Now my lawnmower engine says no 85. I think it's got a, you'll find some of the engines will have, it says no, it has a backslash, it says E85. So they don't want anything any higher or any lower, any more than 85. You know, it's 85% gas, and the rest is the ethanol. They don't want it to be any higher than that. But yeah, so in reality, I found, you know, I think it's in some ways an advantage, but you just need to be cautious about how you store the gas, where you store your equipment, and whether you leave the gas in the equipment at all. I mean, you know, you really don't want to do that with this gas.
Or store it where it can absorb water.
Mm-hmm. Any other questions? If anyone has any issues or problem, you can give me a call and I could try to answer any problems you have with an engine.
Cheryl was doing this.
Oh, Cheryl was waiting?
Well, yeah, John, what you've done is convince me that I need to buy a ramp so I can push my lawnmower into the back of my truck and bring it to your house.
I'll second that one.
Now, really, these are very easy to take care of, you know? So let me ask this question. Any of you that have a lawnmower engine and you get it running in the spring, do you ever have problems with it the rest of the season? Or does it keep running once you get it going?
It's running.
Usually it keeps running.
Yeah. So do you find the ones that are an issue is the leaf blower that you use maybe, you know, don't use all the time, or the weed whacker that you don't use all the time, or the power washer that you use once a year?
Yeah.
Yep.
So it really is kind of the frequency of use. And actually the lawnmower I had before this one was was similar to this Tecumseh engine on the power washer. And I used to have problems with that when it was at my father's house, but once I got it down here and was using it on a routine basis, I didn't ever have problems with that engine at all. It ran just fine after that. And I found that the lawnmower problems, the last two lawnmowers that I retired because the deck rotted out so badly it wasn't safe to run it anymore. I was worried the engine was going to fall out through the bottom. Okay, so is that it for questions? Any more?
That was very interesting.
Yeah.
Well, thanks for tuning in, everybody. Have a good rest of the weekend.
Thank you.
Yeah.
Bye.
Bye-bye.
Thanks, John. Good job.